So where are we? The theories of emulsification. The monomolecular absorption theory, the oriented wedge theory, oriented absorption theory, plastic or interfacial film theory is covered. Next, the surface tension theory. According to the surface tension theory of emulsification, the emulsifying agents causes a reduction in the interfacial tension of the two immiscible liquids, reducing the repellent force between the liquids and withdrawing the attraction of liquids for their own molecules. In this way, the surfactants convert the large globules into small ones and avoid small globules from coalescing into large ones. Okay, next is interfacial tension theory. When two immiscible liquids come in contact, the force causing each liquids to resist breakage is known as interfacial tension. When high interfacial tension existed between two liquids, emulsification is difficult, and if the tension could be reduced, emulsification facilitates. So, what are the theories of emulsification? I have already told the monomolecular absorption theory. Then, oriented wedge theory. In case of oriented wedge theory, in this system containing two immiscible liquids, emulsifying agents would be preferentially soluble in one of phases and would be embedded in that phase. Okay, and oriented absorption theory I have done. In case of plastic or interfacial film theory, the formation of an O by W or a W by O, that means oil in water or water in oil emulsions, depends on the degree of solubility of the agent in the two phases, with water soluble agents encouraging O by W or water in oil in water emulsions and oil soluble emulsifier the reserve. In case of surface tension theory, in this way, in case of surface tension theory, in this way, the surfactants convert large globules into small ones and avoid small globules from coalescing into large ones. And for interfacial tension theory, this this explanation that in oil in water dispersion, the interfacial tension is so great that when two globules of dispersed phase approach each other, it withdraws the liquid from between them, with the result they coalesce. When the interfacial tension is greatly reduced by the addition of emulsifier, the globules remain separated. Okay, next, next is Fisher's theory of hydrates and solvents. Fisher's observed that the use of specific ratios of emulsifying agents to the continuous phase, he claimed that the quantity of water in these specified ratios was all used up in forming a colloidal hydrate. This theory doesn't attempt to explain the formation of concentrated emulsions and not explains how globules in an emulsion are prevented from coalescing and separation into two layers. Next, next is viscosity theory. As per this theory, an increase in viscosity of an emulsion will lead to an increase in the stability. This theory failed to explain about the milk, which shows considerable stability even though its viscosity is less. This theory is holds good for emulsions prepared with gums and emulsifying agents, but it collapse or no explanation of emulsions made which comparatively low viscosity and great stability. So comes to this part, stability of the emulsion. So physical instability or stability of emulsions. Emulsion is considered to be physically unstable if the internal or dispersed phase upon standing tends to form aggregates of globules. Next, large globules of or aggregates of globules rise to the top or fall to the bottom of the emulsion to form a concentrated layer of internal phase. Next, if all part of the liquid of the internal phase separates and forms a distinct layer on top or bottom of the emulsions as a result of coalescing of the globules of the internal phase. In this case, emulsifying agents help to stabilize the emulsion. In spite of best efforts, emulsions tend to be unstable, and signs of instability are enumerated below discussion. Uh, these things are happens for in case of stability of emulsions. First is collations, creaming, flocculation, breaking. I have told previous the Oswald what is was Oswald ripening, creaming, and the aggregation. This aggregation that means joined to each other, collations. After aggregation, collations is done. Then partial collations. First come to this point, flocculation. In this case, neighboring globules come closer to each other and form colonies in the external phase. Okay, this aggregation of globules is not clearly visible. This property, this is probably in the initial stage that leads to instability. The extent of flocculation of globules depends on globule size distribution, charge on the globule surface, viscosity of the external medium. Okay, so flocculation is a process in which two or more droplets stick together to form an aggregate, but the droplets still retain their individual integrity. Uniform sized globules prevent the flocculation. This can be achieved by proper size reduction process. A charge on the globules exert repulsive forces with the neighboring globules. This can be achieved by using ionic emulsifying agents, electrolytes, etc. If the viscosity of the external medium is increased, the globules become relatively immobile and flocculation can be prevented. This can be obtained by adding viscosity improving agents or thickening agents such as hydrocolloids or waxes. Flocks slowly moved either upward or downward, leading to creaming. Flocculation should not be confused with creaming. Flocculation is due to the interaction or attractive and repulsive forces, whereas creaming is due to density differences in two phases. So creaming is a process in which droplets moves upwards when droplet density is lower than the density of continuous phase. That means upward creaming and sedimentation or creaming, that is this thing is also called creaming, where downward creaming, this is called upward creaming, and this is called downward creaming. In this process, which droplets moves downward, where droplet density is greater than the density of the continuous phase. So creaming has two part, that means downward creaming and upward creaming and downward creaming. Upward creaming is when droplet density is lower than the density of the continuous phase, and downward creaming, the movement of droplets of in downwards, where droplet density is greater than the density of continuous phase. Okay, so I have done the flocculation, and now come to this part is creaming. See, here the globules are here, movement of globules is upward, that means upward creaming is done. Here the densities of the droplets are lower than the continuous phase. When the densities of the globules are more than the continuous phase, then this this gathering of globules will be here in the downward. That should be called the sedimentation. So creaming is a concentration of globules at the top or bottom of the emulsion. The floccules moves either upward or downward, leading to creaming. Creaming may also be observed on account of movement of individual globules. It can be observed it can be observed by a difference in color shade of the layers. It is a reversible process. Therefore, cream and cream can be redispersed easily by agitation or mechanical shaking. This is possible by the oil globules are still surrounded by the protective sheath of the emulsifier. This is a potential step towards complete coalescence of internal phase. internal phase. Hence, this stage is also considered to be the mark of instability. Okay, the creaming the drug is not uniformly distributed. This leads to a variable doses, therefore emulsion should be shaken thoroughly before use. We have also